Okay, you guys hear me okay? Okay, great. Well, it's great to be here today. My name is Woloszyn. I'm the Extension Climatologist with the Midwestern Regional Climate Center and Illinois-Indiana Sea Grant. Both are located at the University of Illinois, so we do have to throw Phi and Illini into the mix as well. So very good representative from the Big Ten today. Like he said, I'm going to be talking today about climate trends in the Western Lake Erie Basin. Before we start looking at the trends, I'm quickly going to summarize the climate of Northern Ohio, which I know many of you are familiar with. When we look at the classifications for climate, Northern Ohio has two different types, DFA and DFB climate. The D represents the fact that this is a continental climate, meaning that there's a wide range in temperatures throughout the year between the winter months and the summer months. And that has to do with the fact that this is located in the interior of a continent. The F represents that the precipitation is received throughout the year, and this is also a humid climate. And then finally, the last letter, which differentiates the two different climates in this location, the A represents that this is a hot summer climate in some locations by the darker purple colors, and DFB represents climates that have a warmer summer. And from what you can tell on the screen, those warm summer climates are climates that are actually downwind of Lake Erie. And the reason for that is that the moderating effects of Lake Erie, majority of it happens on the downwind side of the lake. So since it is a continental climate, like I mentioned previously, temperatures are quite variable throughout the year. In the winter time, on the top left, we have temperatures ranging between about 25 and 30 degrees Fahrenheit. I know it's really hard to see the exact contours up there. And in the summer months, temperatures range anywhere between about 70 and 75 degrees Fahrenheit. Along with the average temperature, we also have extremes. There's cold waves in the winter time and heat waves in the summer. In terms of precipitation in Northern Ohio, there's actually a pretty big split between precipitation in the western part of the basin over further to the east. In the west, precipitation typically ranges between about 34 to 36 inches throughout the year. However, the further east that you move, precipitation actually increases up to about 44 to 46 inches annually. And the reason, once again, for this different amounts of precipitation going across Northern Ohio is the fact that we have lake-enhanced precipitation, which is more prominent on the downwind side of Lake Erie. And also with the average precipitation, we also have extremes. Drought is a part of the climate in Northern Ohio, as well as floods, and we're going to talk about both of these in a little bit more detail later. And then finally, unfortunately, or fortunately to some, I suppose, snowfall is also a part of Northern Ohio's climate. In Northwest Ohio, snowfall typically ranges anywhere from about 20 to 40 inches throughout the year. However, for the areas that are affected more by lake effect snow, in the eastern part of Ohio, snowfall normals range from about 40 to 80 inches. So once again, as the storm systems move across the lake, lake effect snow is more prominent on the eastern side of Lake Erie. However, it is possible to get lake effect snow on the western parts of the basin as well. Okay, so that brings us to our first polling question. So the first question is this. Toledo just experienced one of its coldest winters on record. This is just hypothetical, it didn't actually happen. There is no way global warming or climate change are happening. Is that true or false? Thanks. Okay, perfect, thank you. Okay. Okay, let's see. Just as I suspected, many people got this correct. The answer to that is false. And the next slide explains why. So it's important when we're talking about climate that we have to differentiate between climate variability and climate change. Year to year and even decade to decade, the climate of a location is going to fluctuate along some average state, meaning some years will be above average, some will be below, and some will be near normal. So this is referred to as climate variability. And the graph on the right shows the annual precipitation for this region. And it's pretty obvious that there are going to be some years that will see a drastic difference from one year to the next. For instance, in the early 1950s, there was record precipitation, and this precipitation kept the record for several decades until 2011. However, if you look the very next year, there was record low precipitation. So that just shows the variability that can happen from one year to the next. On the other hand, climate change, we're looking at those long-term and more persistent shifts in our climate. So the figure on the left is showing the percentage of the United States with daily low temperatures that are above normal. And it's pretty obvious in this figure that since the early 1970s, there has been a fairly consistent increase in the number or the percentage of the United States that is affected by higher overnight temperatures. So it is safe to say that over the last several decades, this has been a change in the climate that we've been experiencing in the United States. But one thing that's important to remember is that even if temperatures do continue to increase, this does not mean that we will never experience another cold and snowy winter in northern Ohio. In fact, it's very possible that you can have record-breaking cold winter or even a record-breaking cold year. But what's important is to look at the overall trend and see what's happening over time. And so today, that's what we're going to do. We're going to look at regional variables, variable trends for Northwest Ohio, and we're going to look at annual temperature and precipitation. And we'll also look at heavy precipitation events, historical flooding, and drought. At the end, we're going to look at some Lake Erie variables, water levels, temperatures over the basin, ice cover, and evaporation. Okay, so first looking at annual temperature. And before we get into the data, I wanted to just explain exactly what we're looking at on the screen real quick. So this data is data from Northwest Ohio, and the region on the map up here at the top right is showing where this data is coming from. Also, the blue line on this figure represents annual temperature for each individual year. So for instance, if we look at 2012, the average annual temperature was right above about 53 degrees Fahrenheit. The red line on this figure is showing the 11-year moving average. The reason that this line is on the graph is because there is so much noise due to climate variability. The fact that we do have those wide swings from one year to the next, putting the moving average line on this figure allows us to see the trends a little bit better in the data. So it's pretty obvious from this figure that we have seen an increase in temperature in Northwest Ohio since about the early to mid 1970s. And this trend is fairly consistent with what the data is showing for the United States as a whole. Since the early 1970s, our temperatures have ranged from right around 48 degrees Fahrenheit up to about 54. The warmest year was in 1998 when the temperature was 53.5 degrees Fahrenheit. 2012 almost broke that record, but not quite. It missed it by about 0.05 degrees Fahrenheit. So back in the late 1800s into the early 1900s, you can see that this was definitely a cooler period in the historic climate of northern Ohio. Moving into the 1920s and 1930s, we definitely had warmer temperatures, which is pretty consistent with the rest of the country, and then cooler through the 1970s. So overall, temperature trends in this region have been fairly consistent with what climate models are predicting, that there are warmer temperatures over the last several decades, and this could continue into the future. However, remembering back to the earlier discussion, even if temperatures do continue to increase, this doesn't mean that we'll never have a cold winter again. In fact, if you look back at the early 1900s, there's a pretty good example at how temperatures can change pretty drastically in just the matter of a couple of years. In the around 1915, the record coldest year for northwestern Ohio happened, but just about 3 years later, we have one of the warmest years on record for this region. So that shows how things can change in just a matter of a couple of years. Okay, so moving on to precipitation. So once again, the blue line represents total annual precipitation for each individual year, whereas the red line shows the moving average. So precipitation in Northwest Ohio has ranged from the driest year of only having 22 inches to the wettest year of just over 53 inches, which happened just in 2011. And if you look at the record, 2011 really sticks out in terms of annual precipitation. It actually broke the previous record that was set in 1950 by about 5 inches, which is pretty significant. So the trend in annual precipitation is a little bit less obvious, but it can be said that since the 1990s, we have seen a slight increase in our overall annual precipitation. Some might even argue that this trend started in the early 1970s, but in 1990s is really when we started to see precipitation above what it was historically on average. So that's what's significant. So one thing that's interesting to look at is the fact that 30 inches of precipitation has not happened, or I should say lower than 30 inches of precipitation has not happened since the early 1990s. However, looking at the historical record, you can see that less than 30 inches of precipitation was pretty frequent in the historical record. So it will be interesting to see how this trend continues into the future. If we'll continue to see that increasing trend in our annual precipitation, or if we'll start to see it go back to around the normal of around 35 inches. I know Jeff might talk about this a little bit more in the next talk when we look at projections, but some climate projections are showing that annual precipitation might not change all that much in the future. But what might change is how much rain falls during each event, meaning that we might have heavier precipitation events. So if we have heavier precipitation events, but the annual precipitation remains about the same, that means that we might have longer periods of dry conditions in between. Okay, so our next polling question is, climate data in Northwest Ohio indicates that there has been an increase in what size precipitation event over the last several decades? Is it in the smallest events from 1/100th to just less than 1/2 of an inch, 1 to 1.49 inches, 1.5 to 1.99, 2 to 2.49, or is it B, C, and D? These are just meant to be kind of fun. It's not, don't worry too much if you don't know the answer. Okay, almost slowing down. Okay, let's see. Ah, very good. The correct answer is E. B, C, and D, we have seen an increase in these larger precipitation events, and the next slide shows a little bit more information about this. So this is information for Sandusky, Ohio, which has a pretty good climate record dating back to the late 1800s. So what this figure is showing us is the frequency of large storm events. So these are storm events with daily totals 1 inch or greater. The blue columns are representing the events or the frequency of these storm events from before 1970. And the red bars represent events after 1970. On the very left, we see precipitation events ranging from 1 inch to 1.49, and greater precipitation events to the right, ending with 3-inch events on the far right. So from this figure, we can see that the greatest increase in our large storm events has happened for events ranging between 1 inch and 1.49 inches, and we can see the difference in frequency between the bars. We also have seen the increase in 1.5 to 2.99 events as well. We've actually seen a slight decrease in the 3-inch events, but it's really not too significant. So one thing that's actually not shown on this slide is that we have seen fewer small events ranging from just 1/100th of an inch to 0.49 inches. We have seen less of those over the last few decades. So these findings are pretty consistent with what was found in the 2013 National Climate Assessment for the Midwest. In general, there's been about a 4% increase per decade of the 24-hour 5-year storm across the Midwest since the beginning of the 20th century. So these trends that we're seeing in heavier precipitation events are not just happening here in Northwest Ohio, but also throughout the Midwest. Okay, so the next polling question is, a significant historic flood caused this March to be the rainiest on record in Northwest Ohio. Is it March 1913, 1937, 1964, 2008, or 2011? Okay. It's actually March 1913, so just the 13% of you that got that correct, good job. Not surprised with March 2011, we just talked about the fact that 2011 was very high for precipitation. But the event that caused March 1913 to actually be so significant is the historic flood that happened over Easter weekend. Throughout this month, many locations in Ohio recorded anywhere from 10 to 14 inches of precipitation, which is about 8 to 10 inches higher than normal values. And so the flood of 1913 came over Easter weekend, like I said, and it produced a lot of damage across the Ohio River Valley, across Indiana and Ohio. During this storm, about 6 to 10 inches of precipitation fell, which is shown by the purple areas on this map. There was over $300 million of damage and over 600 deaths were attributed to this event. So recently, there was a commemorative event for this 1913 flood because it was the 100th anniversary just this past March. And there was an anniversary or commemorative event led by the Silver Jackets, which is a national flood mitigation program. And one of the main purposes of this 100th anniversary event was to really get people to think this event has happened in the past. It is possible that it could happen in the future as well. And to look at what the differences might be between today and 1913 if this type of event were to happen again. And it was found that there would still be very extensive damage across Ohio communities if this type of flood happened, which actually would still meet or exceed the 500-year flood event. However, because of mitigation techniques over the last several decades, overall damage would be minimized and there would be a dramatic reduction in the loss of life, luckily, because of better warnings and better building techniques. However, even though this storm would not cause quite the damage that it did back in 1913, it still would have a major impact on Ohio. So it is important to think about this type of storm and to plan for it in the future. The 100th anniversary website is listed here on the bottom right of the screen. So if you want more information on that storm, you can go to that website, and it also has a really good section on flood awareness and flood mitigation. So the opposite of what we were just talking about with heavy precipitation events, Northwest Ohio has in the past, presently, and most likely in the future will deal with drought. In fact, in 2011, it was especially bad for the agriculture community in Ohio. In September, the U.S. Department of Agriculture named 85 of Ohio's 88 counties as natural disaster areas after rainfall shortages and really high heat drastically affected agriculture in this state. So this figure shows that 2012 was actually nowhere near the worst drought that has been experienced in this region. The driest time in Ohio's history was around April 1930 to March 1931. Even though this is the driest on record, we have had longer periods of dry conditions in this region. And that happened in the late 1800s, throughout the 1930s pretty much, the early 1950s, and the 1960s as well. And I should have mentioned, this figure is showing the Palmer Drought Severity Index, which uses temperature and rainfall to determine dryness. So the red values are showing the drought and the blue are showing wetter conditions. So based on this, we can see that the last few decades we have had more frequent years of wet conditions, and our droughts have not been quite as long or severe as they have been in the past. So moving on to the last regional variable, which is wind. This figure from the Department of Energy shows that Northwest Ohio is the windiest part of the state. However, unfortunately, due to the fact of some data issues with wind information, it's really hard to find studies that talk about the trends in wind speeds over time. However, there was a study done in 2009 that found in general in the Midwest, there really has not been any great change in speed distributions since the early 1970s. However, looking specifically at one type of wind event called a derecho. Have you guys heard of a derecho before? Pretty familiar with it in this part of the state, I would guess. So a derecho is a widespread, long-lived storm that tracks across usually a wide area, bringing really strong straight-line winds across its path. A derecho is defined as a thunderstorm with outflow winds exceeding 75 miles per hour across several different points along its path. Most recently, one of the most destructive storms to make its way across North America was just last June when a derecho tracked across 600 miles from Indiana all the way out to the Atlantic Ocean in just 10 hours. The average wind speeds throughout this storm were 60 miles per hour, but there were peak wind gusts on the order of 80 to 100 miles per hour. As this storm moved across the eastern United States, it did bring pretty great damage. This is a picture from some of the damage in Columbus Grove, Ohio. There was also millions of people that were without power on the order of a week or even longer, including over 1 million customers in Ohio, which represented about 2/3 of the state. So it seems like these derechos have become more frequent in recent years. So what is the data showing about these events? Unfortunately, there are not a lot of recent research that talks about the climatology of derechos. The last study that was done in the eastern United States was back in 2004. And it looked at the number of moderate to high intensity derechos, and this is a figure showing the climatology, or the number of those derechos, over about 2 decades. And what this study found is that there are typically 2 main tracks that these derechos take across the United States. One of which is across the Southern Plains, Arkansas region, and the other is across the upper Midwest and into the Ohio River Valley. And this study found that from the mid-1980s to the mid-1990s, there were more derechos that moved across this southern axis. However, starting in 1996, derechos were more frequent across the northern axis. Unfortunately, this data did stop in 2001, so now it's more than a decade outdated. So I wish I had more information on what the last 10 years or 12 years were telling us, but unfortunately I do not. But based on what we saw on the previous slide, we can tell that these events are very damaging when they do occur, and it is possible that they have become more frequent across the northern axis and the Ohio River Valley in recent years. Okay, so moving on finally to Lake Erie climate trends. We're going to look just briefly at water levels, temperature, ice cover, and evaporation. So Lake Erie water levels have been quite variable since records began in 1860, and this is true across all of the Great Lakes as well. The data shows that Lake Erie water levels have ranged between about 173 meters and about 175 meters over the period of record. On this graph, the blue dots are showing our average annual lake level, and the black lines are showing what the minimum and maximum lake levels were for each year. And once again, we have the 11-year moving average line on this figure showing us a little bit more about the trends over this time. So you can see that since the early 1970s, we have seen a decrease in our lake levels on Lake Erie. However, it's really not comparable to well, it is comparable right now, but the trend from the late 1800s to the early 1930s, where we saw this drastic decrease in lake levels over that time, bringing us to some of the lowest lake levels in the 1930s of 173 meters. Just recently, in May 2013, the current lake level on Lake Erie was about 571 feet, or about 174 meters, which is about 8 inches below the long-term average, or about 0.2 meters. Because of all the things that go into determining what water levels are on Lake Erie, it is difficult to tell what might happen in the future. Looking at the over-basin temperature for Lake Erie, we see the same type of data that we saw on the land stations in northwest Ohio, where we do see an increase in temperature since the early 1970s. The temperature over Lake Erie does have a big influence on other variables like ice cover and evaporation. And this is showing ice cover on Lake Erie since the early 1970s. The blue diamonds are representing the average annual ice cover each year, while the red line is showing the moving average. And it would make sense that if temperatures increase, we are going to see less ice cover over Lake Erie, and that's indeed what the data is showing us. The other thing that's shown on this graph is the maximum ice cover for each year, which is shown by the green dots. And you can see that in a majority of the years since the 1970s, ice cover maximum has ranged between about 90 and 100%. However, one thing that's interesting to look at is that there have only been 4 years with maximum ice cover less than 25%. And all 4 of those years have happened since 1998. That was 1998, 2002, 2006, and 2012. So we definitely are seeing more years recently with less ice cover than we have over the last few decades. And finally, moving on to evaporation, which is greatly influenced by the previous 2 variables. The higher the temperatures are, the more evaporation that can happen off of the lake's surface, because evaporation is greater at higher temperatures. Also, with less ice cover over the lake, more of the water is exposed to the atmosphere, meaning we can have greater evaporation. So it does make sense that since the early 1970s, when we've seen higher temperatures and less ice cover, we have seen an increasing trend in the amount of evaporation off of the lake's surface. However, it is important to remember that evaporation, there's other things that go into it instead of just precipitation, or instead of just temperature and ice cover. Other things like wind speeds, cloud cover, and precipitation also have an effect. And also, in the future, if we were to see more precipitation, that means that we could offset some of the evaporation that's happening off of the lake surface. Once again, making it pretty hard to determine what might happen to lake levels in the future. Okay, Okay, so that is all I have to show you today. If you guys have any question, I'd be happy to take them. Thank you.